The moon. Okay, so this is one of those talks where it's like, oh, hey, look, there's some cool idea, but I'm going to trick you. I'm going to talk about something else. So I'm just go ahead and warn you. I'm talking about something else, really. But I'm starting off talking about the moon. So let's look at the moon. This is the moon. This is a great image, a composite image of the moon over its full cycle. And so you can kind of see how it moves. You can see the shadow, the phases of the moon. There's really some cool things that you can see here. I think the phases of the moon are really cool to begin with. A lot of people think what causes those phases of the moon. It's the Earth's shadow on the moon. It's not the Earth's shadow on the moon. In fact, the phases of the moon are just caused by the orientation of the Earth, Sun, and Moon. So half of the moon is lit up, and you're looking at the half of the moon that's lit up is facing the sun, but we look at it from different angles. So that's what causes the phases of the moon. But I don't want to talk about the phases of the moon. Look at that moon. This is the whole time that it's orbiting the Earth. And you'll notice that it moves around a little bit, but we still see the same side of the moon all the time. It's the same features on the moon. We don't see the whole moon. We see a little bit more than half of the moon. Now, there's some other cool things, the wobble, the orientation. These are other things related to the orbit of the moon around the Earth, but I don't want to talk about that. Let's talk about this, tidal locked orbit. So here you can see the moon in two different locations. It's that red-green thing I drew right there because even though the moon is not red and green, I drew it that way anyway. As the moon orbits the Earth, it also rotates in a way that the red side faces the Earth and the green side faces away from the Earth, no matter where it is in the orbit. And so we call that green side that we can't see from the Earth, we call that the dark side of the moon. Now, in reality, it's not always dark over there because it depends on the sun, not on the orientation of the moon. But the key thing is that the moon is tidally locked because of the gravitational field from the Earth and the non-symmetrical features of the moon, and it's locked. Okay, so now let's look at a globe of the moon. This is an actual model. I found this in an old stock room. I'm going to rotate it around here. The back is completely blank. I think that's awesome. The part that is mapped is the part that we see, and the back is just plain blank. So let's think about why this is. So the moon takes about 28 days to go around the Earth. It also takes about 28 days to rotate around its own axis. That's what tidal locking means, that the rotation and the orbit are fixed. This particular globe was made in the 1960s by Edmund Scientific. We as humans had no idea what was on the back side of the moon, the dark side of the moon, until the 1960s. So this was made right around the time of that globe. And right around the time that the Russians went and saw the back. So at this point, the globe was made, let's look at that again. The globe was made without any idea about what was on the back side of that moon. So they just left it blank. They didn't know what was there. Okay? So, what does that mean? This tells us something about the nature of science. And you get to the part where I wanted to get to, which is, what the heck does he want to talk about? He wants to talk about science. And this globe, moon globe, is a great example of the nature of science. Science is a process of building and testing and refining models. And that moon globe is a model of the moon. And it's incomplete because we didn't know it was there. And that's okay. Models don't tell us the truth. So let's look at a few other models. The two equations are two different models for the gravitational force. I like these two models because the one on the right, F equals mg, we see that. It says the gravitational force is constant and we can calculate it. But it's not. That model's wrong. the equation on the left is a better model for gravity. It says that the gravitational force decreases with distance. So even that model is wrong. It doesn't take into account things like gravitational waves. So we build these models and we know they're wrong, but as long as they're still useful, that's okay. You can use the model for gravity that is constant, and you can use that to build an airplane and fly to London, and it works. You don't have to use the complicated form of gravity. So we know that it doesn't work. But so models are just that, they're models. So we have a couple other models. I have an energy chart here that shows the interaction between objects, like when a hand pushes a cart and makes it move. And so it doesn't have to be a mathematical equation for a model. It can be a conceptual idea. And then we have this computer program here that I wrote. That's another model. We can make a computer program as a type of model. So we have all these types of models. And this is what we do in science. We build these models, and they don't have to be equations. They don't have to be physical models, but they can. They can be conceptual models. They can be computer programming models. But models are just models. They don't tell us the truth. They just model things. We know if a model is wrong. If I had Disney World on the back of that globe model and I sent the Russian spacecraft behind there to take pictures and there's no Disney World, then I know that that's wrong. Okay. But I don't know that it's right. Even then, when I take pictures, what's on the inside of the moon? What's the rest of the model? I never know the end of that model. Sometimes these models are wrong, and that's okay. Even if we know they're wrong, they can still be useful. And finally, one last point. Why do we do science? Why do we make these models? We do that because this is part of what makes us human. We study science in school because we study things that relate to our humanness. And science is one of those. Art is one of those things that makes us human. Literature, acting, building things. These are all things that make us human, and science is one of those things.